Welcome students. Today we are going to start the second group, that is arithmetical group. Arithmetical group. So we are studying the instructions of 8085 and we have seen already that there are 5 groups depend upon their operations. Now first we have completed data transfer instructions. Now here is arithmetical group of instruction. Arithmetical group of instructions. Now we are going to study the arithmetical group of instruction, in which first instruction that we are going to study, that is add. Add. This is a numerics. Once again, what is in my numerics? It is the short word for a activity. Actually, microprocessor can understand the instruction of 190 that we know very well, but the instruction of 190, remembering it, looking toward it, we can't predict its meaning. But when that instruction is executed, what happens? It's short word that is called as numerics, and we are studying the instructions in the form of numerics. So this is the add instruction, arithmetical group of instruction. Add what? Add register or memory to accumulator. What is it by add register or memory to accumulator? So, what is accumulator? Accumulator is it is 8-bit register. It is 8-bit register. We know that what is in the register? That is a memory elements, microprocessor, broadly divided into 3 parts, that is ALU, who perform the arithmetical logical operations, registers for temporary storage, and control unit. So depend upon the microprocessor, there are various types of registers. In 8085 there are there are 6 8-bit registers. 6 8-bit registers. Those are A, B, C, D, E, H and L. So these are the 6 8-bit registers. So among that, A is called as accumulator. Why the A is called as accumulator? What is the function of accumulator? And remaining all these called as general purpose registers. General purpose. Among that, again, B and C can be formed a pair. D and E can form a pair. H and L can form a pair to store the 16-bit data. Now, here more specifically we are going to see what exactly is the accumulator. It is 8-bit register. It is main register. It is 8-bit main register. Main register. Whenever arithmetical and logical operations are carried out, at that time one of the operand is held by accumulator. It holds one of the operand. It holds one of the operands. When instruction is executed, arithmetical instruction is executed, result is also held by accumulator. Result is also held. Result is held by activity. destination register. So these are the functions, three functions of the accumulator. Accumulator is the register. It is 8-bit register. But why it is called as a main register? Because whenever arithmetical logical operations are carried out, it holds one of the operand. Result is held by accumulator. It is also source as well as destination register. Source as well as destination register stands for whenever data is taken from input device, it is available in accumulator, and whenever data is sent on output device, it is transferred from accumulator. So here is add register. Any register, that is B, C, D, E, H, L. Any register or memory location to accumulator. So obviously add R. Add the contents of register. Which register? Here R is register. Which register? That is A, B, C, D, E, H, L. Any register among these A, B, C, D, E, H, L, it may be there. And this is called as upcode. So you can answer, where is the second operand? Only R is there, and R is A, B, C, D, H, L. So here one of the operand is along with upcode. So operand is register. Operand is register. So length is 1 byte. Number of machine cycle obviously will be upcode fetch. Number of machine cycle 1, and P state 4. Or it may possible that you can add the contents of accumulator with the contents of memory location. M stand for memory location. Here M is memory location. Memory location. But which memory location? Whose address is in HL? Whose address is in HL? So add here. So this is also length if you find the machine code 1. But when upcode is fetched, it knows that it has to add the content of memory location. Which memory location? Whose address is in HL pair? So it will go to HL pair, it will ask the address, and the data will be taken from that memory location. Thus number of machine cycle will be 2 and P state will be 0. So this is the add instruction. So if question is asked in the examination, explain the instruction add R. How to answer? This is one byte instruction. When this instruction is executed, contents of register may be A, B, C, D, H, L, is added with the contents of accumulator, where the accumulator is implicit. And after executing this instruction, result will be stored in accumulator. So how to explain this instruction when instruction is asked? Add the content of register mentioned with the contents of accumulator, and after that store the result in accumulator. So after that it sets all flags. And suppose the question is asked in the examination, explain the following instruction, add M. Then you have to write the answer. Add the content of memory location. Which memory location? Whose address is in HL pair. With the contents of accumulator, store the result in accumulator. So this is the instruction. You can take that. Now, let us see the next instruction. What the next instruction is. Next instruction is same, but the code that we are going to see. Second instruction of arithmetic, ADI, add immediate what exactly by immediate? Immediate data. Which immediate data? Immediate data is after opcode. Now remember the immediate addressing mode. In immediate addressing mode, explicit operand is the data. When data is itself operand, then addressing mode is called as immediate addressing mode. Add immediate to accumulator. So add immediate data. So opcode ADI operand data. Where the implicit operand is along with opcode, that is accumulator. So obviously length opcode always 1 byte and data is immediate data. Example you can see ADI 03H. What exactly mean? Add the immediate data 03H with the contents of accumulator, store the result in accumulator. Whereas in previous instruction we have seen, say add the contents of register B with the contents of accumulator, store the result in accumulator. See the difference? So this is the 1 byte instruction only, but here this is the 1 byte and this is the other byte. That's why length is 2 byte. So number of machine cycle will be opcode fetch. Now it has got what it has to do, add. What to do, add? What to add? Immediate data. Where the immediate data is after opcode. So after opcode there is immediate data that it has to bring from memory location. So that is immediate data that will be added. Thus number of machine cycle will be 2 and this state will be 7. Opcode fetch, memory read. Here we can say, here data is 8-bit immediate data. Any immediate data from 00 to FF. Now when the question is asked in the examination, explain the following instruction, ADI data, how our explanation should be. This is 2 byte instruction. First byte gives opcode. One of the operand is implicit. Who is that? That is accumulator obviously. Because already we got that functions of accumulator, that is whenever arithmetical logical operations are carried out, one of the operand is always along with opcode. Another operand is 8-bit immediate data. When this instruction is executed, this 8-bit immediate data which is after opcode is added with the content of accumulator and result will be stored in the accumulator. Here data is 8-bit immediate data. So take down this instruction. Now the next instruction we are going to see, third instruction. That is ADC. Same as add, but C stands for a carry. Add register or memory with accumulator to accumulator with carry. Then what is the difference between add and ADC? Add the contents of accumulator. You see, this square bracket indicates that contents of, how to read it? Contents of. Add the contents of accumulator plus contents of register or memory. ADI. Add the contents of accumulator plus 8-bit data. And here third is ADC. content of carry flags. CY. What is stand for CY? For that we have to see flags. It is a flag. One of the flag. So before we study this instruction in detail, we are going to see what is meant by exactly flag. Flag or flags. As we have seen that register, it is a memory element. Register, a microprocessor is broadly divided into three parts, that is ALU for arithmetical logical operation, CU control unit, register for temporary storage. So flags are also register. Suppose question is asked in the examination, make the list of registers of 8085. Then you will make the list. Register A, that is accumulator. Register B, C, D, E, H, L and flags. Flags are also register. But A, B, C, D, E, H, L, all these are the 8-bit register, whereas the flags are only 1-bit status register. Flags. Flags are 1-bit status register. One bit status register. You see, status register, which is set or reset. Set, it means it is set to 1. Reset, it is set to 0. But how it is set or reset? Depend on nature of result. Nature of result. And who produced the result? Produced by ALU. Produced by ALU. So you take down this. ALU. ALU. Definition of flag you can see. Flag is 1-bit status register which can be set or reset, depend upon nature of result produced by ALU. So the question is asked, this is the definition of flag. How many flags are there in 8085? Flag. Here the definition of flag is 200. Now flags of 8085. Flags of 8085. So there are 5 flags. There are 5 flags in 8085. Flag is 1-bit status register. It can be set or reset, depend upon nature of result. Whenever any activity is performed, we can make the analysis. Similarly, whenever arithmetical logical operation is produced, depend upon nature of result. Result is analyzed and depend upon that flags are set. So there are 5 flags in 8085. That is CY, that is carry flag. Number 1. Number 2. Actually, there is a diagram that we are going to see. There are 5 flags. So this is the diagram of flags that we are going to see, and the flags are as follows. Yes, Z, yes, Z, A, C, P dash C. Yes, sign flag. Sign flag in bracket, yes, number 1. Z, 0 flag. Three, auxiliary carry flag. Auxiliary carry. Auxiliary carry AC. Fourth, P, parity flag. Parity flag. P. And last, there is carry flag. C1. You see? So, first we have seen what is the flag. Then flags of 8085. How many flags are there? Their names. Now question arises, how they are set or reset. They are set or reset depend upon nature of result. Suppose after the arithmetical logical operation, say accumulator is 08 and register B is 05 H and instruction is add B. Now look at this, accumulator is 08H, register B 05H. So first of all make the 1 and 0. 0, 0, 0, 0, 1, 0, 0, 0 and 5, 0, 0, 0, 0, 0, 1, 0, 1 and instruction is add 0, 1, 1, 0, 0, 0, 0, 1, 1, 1 and 0, 0, 0, 0. This is the result. Now look at the result. Is there any carry produced? No. So carry flag will be set to 0. What is the MSB bit? 0. Then sign flag is also 0. Looking toward the sign MSB bit, sign flag is set. 0 flag. You see the answer. Answer is 0 or non-zero. Answer is non-zero. That's why it is also 0. AC. If there is a carry produced from 3rd bit to 4th bit, no carry from 3rd bit to 4th bit. You see, that's why it is also 0. Parity. How many ones are there? 1, 2, 3. 3 ones are there. Odd parity. 0. Even for even parity there is 1 and there is no carry. So this is the flags. So flags. The flags we have to see. And apart from these flags, we are going to continue the instruction ADC tomorrow. I think you have got the flags at least. Thank you.